Hello. This is a deep dive video for the OpenAthena API, which is a simple online RESTful API recently published at api.openathena.com. Um, our OpenAthena software introduces a novel terrain-raycast technique for remote sensing by drone. And basically, any single pixel of a single drone image, the software is able to geolocate it within 8 milliseconds and to within 10 meters. So it's a really, really useful capability for time-sensitive situational awareness and common operating picture from drones for a variety of applications like search and rescue, public safety, law enforcement, and defense. Basically anything where that time-sensitive situational awareness from drones is really critical. And basically with this terrain raycast method, we remove the need for having a laser on board the drone. So that saves typically $40,000 to $100,000 per device. And it means we don't have to move the camera at all to like center a target within the camera frame. And It also means that we can use a wide variety of regular off-the-shelf drones for instantaneous location sensing. So yeah, basically what we've designed here with the API version of OpenAthena is a simple online API that allows other developers to integrate this capability into their own drones and their own hardware and software applications. So basically for this API, we don't need, entire drone images to be able to geolocate. All we need is just the location and orientation of the drone camera and the spot in the drone image that we're interested in. So here we see an example of a request made to the API where we're just feeding it the latitude, longitude, altitude, yaw pitch roll of the drone camera, and basically the spot that we're interested in. And then within like 8 milliseconds, it spits out the distance from drone to target and then the calculated latitude and longitude and altitude of the target on the ground. So yeah, now that's not extremely interesting to see that like in text, just text output. So we've also developed this graphical application called OpenAthena Desktop, which is basically an example client of this API. And it's a graphical user interface that under the hood is sending requests to this api.openathena.com. So I'm going to show just a simple example here with a regular consumer drone image and basically talking about how the software operates and actually does that calculation. So as soon as a drone image is loaded, the software is going to extract EXIF and XMP metadata embedded in this image that describe the position of the drone, the orientation of the camera, zoom level, and a bunch of stuff like that. And then for any single pixel that the user selects, it is able to measure that in terms of where it is in the camera frame, and then use that for calculating the angle within the camera of that specific pixel. Um, and then basically it uses those, feeds that as a request to the OpenAthena API, and then it performs that terrain raycast calculation and spits it back as a latitude longitude, or it supports like US National Grid, lat long degree minute second, or even NATO MGRS or cursor on target to ATAC. So it supports a variety of formats basically for whatever use case is desired. And not only can we do center field of view like many different systems out there, we can get any arbitrary pixel within the camera's field of view. That's really nice because if you're doing post-processing on data or you're flying the drone live, you don't have to slew to cue the camera's aim onto whatever you're interested in every time. So that gets you a lot more out of the data that you're already collecting and makes it much more useful for some of these time-sensitive remote sensing applications. Some possibilities, for instance, are feeding object detection AIs into this, where the bounding box within the image can be, geolocated, letting a human operator, specify something of interest that maybe they didn't notice until after flight, that kind of thing. So yeah, under the hood, all this is doing is basically sending a API request to that API server at api.openathena.com, and then it gets the response back with that geolocation. Um, so I'm going to show kind of what that actually looks like under the hood, what this is doing for the request it's sending to OpenAthena. So here I'm using a instance running locally, but if you were to do this, you would just replace this part here with https://api.openathena.com. And basically, if you visit that site with your web browser, it'll show you this document with the API specification. But if you use it through like a client like this, sending a request, it processes it differently and treats it as an API request. So basically, I feed it my API key, which authenticates me with the service. I give it the latitude, longitude, altitude of the drone, the yaw, pitch, and roll angle of its camera, and then some other parameters like the drone model that it actually is uh, being used, and then the spot in the image that I'm interested in. This is measured from 0 to 1.0 and the X and Y axis. It's measured from the top left corner of the image, increasing rightwards and downwards. So, for instance, the center of the screen would be 0.5, 0.5, and the bottom right corner of the screen would be 1.0, 1.0. And basically, as soon as we feed those values into the API, it does a terrain-raycast calculation. It's a very quick O of 1 operation. And then it spits out that target coordinates, the anticipated maximum error, and yeah, that's basically it in terms of the most interesting functionality. Now it also supports specifying which data set we want to use. In the US and Canada, the most accurate data set available is the USGS 3-dep data set, which comes from LiDAR survey, and it measures very accurately that bare terrain height in the absence of forests and buildings. So that's what we use by default in the API, but we also support other ones, including global models such as the Copernicus 30-meter dataset, um, and that works pretty well as well. And then the API also has a bunch of different features, like if we're interacting with it. So for instance, if I show here, um, in this graphical interface, which is using the API, it's able to see stuff like the different areas that are covered by the elevation data that we've already downloaded. It allows us to specify a new area for preloading data. For instance, say we want to use it offline or something. Um, it also supports searching for a specific area, looking up the altitude of a given latitude, longitude, just from a digital elevation model. It lets us search the database of drone cameras that we've already calibrated and are pre-configured in the software. And there's even an admin interface that can be used to like manage a specific instance. Um, and that all that functionality is basically driven through this API, and we've made it a very simple modular format so that other software can basically integrate into this and get those capabilities out of it with low friction. So yeah, so an example of one of the other kinds of API requests other than just calculation um, is like this one, let's say, which actually shows the different elevation files which are loaded and their coverage area. Now, this is pretty ugly to read as a human, but for a machine, this is very simple to parse and then figure out which areas are preloaded and ready to calculate on. If you send a request for an area that has not been downloaded, the software will do that automatically, and then use that downloaded data for any requests coming in thereafter. We can also tell it to prefetch a DEM for a specific area so that we can do faster calculations later. Um, and basically, it takes up to 10 seconds for actually downloading that elevation data. It's typically like 400 square kilometers. Sorry, no, I'm doing my math wrong there. 40,000. It's a big area. But that lets us like pre-cache areas for faster calculation thereafter. And then, of course, if I do a calculation in the covered area, it'll be just about instantaneous once that data is already downloaded. Um, and it's all doing that on the server side, so it makes it very, very lightweight and simple for the client who's actually calling that API. So we support a database of over 106 different drone cameras, which we've already done calibration values for being able to calculate, the angle for a given pixel within the image frame. If you have a new drone or a custom drone or camera that is not recognized by our software yet, the API allows you to basically put in the properties of that camera to be able to do location calculation. So the main things that the software is looking for when it's using a unknown camera model, basically you have to feed it the size of each individual pixel, like the physical size of a pixel on its sensor, also known as its pixel pitch. We usually convert that from micrometers to millimeters just by multiplying by 1,000. Sorry, dividing by 1,000. And then the type of lens that it is, most of them are perspective, and then the lens distortion parameters for the given camera. So you don't have to figure out all these yourselves. We've published a very simple camera calibration tool on our GitHub where basically you take a few dozen photos of this checkerboard, black and white checkerboard pattern poster, and the software just calculates those values and spits them out for you. We even offer to ship one of these calibration posters to you on site if you need one to be able to do that. Very simple, very easy process. But basically, once you have those values and it's either in our database or you supply it here in the API, that lets you get any arbitrary point within the camera's field of view for her location calculation. Um, so in this instance, I'm pretending that this is an unknown camera model, and I'm saying its make name is custom, model name is drone model, and then I'm feeding in all these camera parameters. And we can see that it works just like a pre-calibrated camera model that we already recognize. Pretty much any regular consumer off-the-shelf drone is going to be already known by our software with that database that we maintain. And yeah, so basically any of our clients who are interested in building an application using this API, what we do is we give them this desktop version of the software as a piece of open source software that basically just gives a practical example of how to use the API, within a different piece of software. So we've designed it to be extremely simple, modular, open systems architecture where this capability enhances maybe other manufacturers' platforms, a variety of different drone models, hardware, software, basically a low friction, extremely modular, loosely coupled capability for getting that time sensitive location intelligence from drone remote sensing data. So yeah, if you have any questions or to request a key for this API, feel free to reach out to us at info@theta.limited or the email address here at api.openathena.com. And we'd be happy to get you a key for testing and evaluation. Thanks. Goodbye.